Hi, welcome back to Statistics 1. We're up to lecture 23, almost at the end. The topic of today's lecture is the generalized linear model. Not to be confused with the general linear model, which we covered back in lecture 12. So in this lecture, I'll compare the generalized linear model to the general linear model. So I've divided this lecture into two segments. In the first segment, I'll just give you an overview, sort of a conceptual understanding of the generalized linear model and how it relates to what we talked about before, the general linear model. And then in the second segment, I'll give you just two examples of the generalized linear model in action. So let's jump into this first segment, which is just a conceptual view of the generalized linear model. So to be clear, the generalized linear model is an extension of the general linear model, which we covered back in lecture 12. It allows for non-normal distributions in the outcome variable, which then allows us to test for non-linear relationships between a set of predictors and that outcome variable. Remember, those were two of the main constraints when we reviewed all the assumptions underlying the tests that we covered in this course. It was sort of, we felt constrained by the fact that we had to assume a normal distribution in Y and we had to assume a linear relationship. The generalized linear model was developed to allow us to move beyond that, but still based in this same kind of framework as the original GLM. Now, since they sound exactly the same, I'm going to just call the generalized linear model GLM with an asterisk, and the general linear model, as I did before, just the GLM. So to review the GLM, because it's been a while, it's about halfway through the course, we talked about the GLM when we were talking about multiple regression, is where I introduced the GLM. It's just the mathematical framework that was underlying all of those procedures that we were conducting. So multiple regression and ANOVA in particular. The main assumptions, of course, were that the relationship between the predictors and the outcome were linear and that they were additive. All right? That's the main gist of the GLM. And we covered that in the context of multiple regression and then again in ANOVA. Remember, ANOVA is just a special case of regression, a special case of the GLM where the predictors are orthogonal. Remember, that didn't preclude us from testing nonlinear relationships or dealing with non-normal variables, right? So there were some situations where what I call a quick fix got us by and we could use the GLM. Just like a quick fix got us by in a lot of parametric procedures, we didn't have to go to non-parametrics. We could just use the parametric and we could use the GLM. So for example, we could transform our variables so that linear relationships looked linear, that nonlinear relationships look linear. And we did things like moderation analysis, which faked out the GLM, and by adding in a product term, we were able to test effects that were non-additive, like an interaction effect in moderation analysis or in factorial ANOVA. So remember, a simple regression was sort of the easiest example of a GLM, but then sort of more interesting examples were multiple regression and factorial ANOVA, right? And here's an example of what I was just saying is where we faked the GLM into testing a non-additive effect. So we just put in a product term and that tested to see if there were non-additive effects or not. Sometimes we just can't we can't apply a quick fix, we can't do a simple transformation, and that's why this generalized linear model was produced. It allows us to test for nonlinear models. It allows us to deal with non-normal distributions in the outcome variable. So it's very flexible and dynamic. So it's appropriate when simple transformations or product terms aren't sufficient to allow us to deal with our data. And the key to the GLM star is that the linear model is extended and allowed to generalize to other forms by adding what's called a link function. So the link function is key to making the GLM star more flexible and generative. And that's the key difference between the GLM and the GLM star is the link function. So for example, in binary logistic regression, the logit served as the link function. What do I mean by that? It's just right here. So remember, this looks exactly like the regular old multiple regression that we used in R. We could use the LM function, right? But it has this extra piece on the left-hand side of the equation. That's the link function. And in binary logistic regression, the link function is the logit function. So we apply that transformation or that link function, add it onto the GLM, and it becomes GLM star. That's it. That's the sort of brilliance and elegance and simplicity of GLM star, is we can just add in any link function that we want. It doesn't have to be a logit. It can be any other kind of link function. And then we can test for other kinds of nonlinear relationships. So here it was logistic. If we have other kinds of nonlinear relations, we just apply a different link function. And GLM star can handle that. So to wrap up this introductory segment, just to give you the concept, GLM star is just a simple extension of GLM. Simple in the fact that all you do is apply a link function. Not so simple in that that link function can be one of many different kinds of functions that show nonlinear relationships between a set of predictors and an outcome variable. So I say it's sort of a simple extension, but it allows for lots and lots of other types of regression models to be tested. So I'm just giving a quick summary of it here. Again, we could do a whole nother course on nonlinear regression where we would start here with the generalized linear model. So again, if you're dealing with data that sort of don't fit the assumptions that we've been dealing with in this course, then I would advise you to look for a course on nonlinear regression or look further into this generalized linear model. So it's appropriate when simple transformations don't get us past those violations of assumptions. And the key is by adding in this link function, we're able to extend the linear model to any other kind of model. So we can, any other kind of function, logistic or any other kind of function we want, we can throw in by adding this link function to the left-hand side of the regression equation.